Okay, let's do another example in which we will be able to find the standard deviation of a normal random variable with mean equal to given number 6 and one probability for that x given. Well, here, as we always deal with the normal random variables, we cannot do it without turning it into standard normal random variable. So the first thing is recall that every time you have a normal random variable like x, if you subtract mu from that and then divide it by sigma, the resulting random variable is the standard normal random variable. And in this case, we have what is mu. Mu is 6, and sigma is we don't know. We need to find it. Okay, what else we know? We know that also probability of x less than 5 is equal to 0.4013. Okay, so let's work on this probability of x being less than 5. Well, it is given that this is 0.4013, and well, we need to turn it into z by subtracting both sides, 6 from both sides. So x minus 6 is less than 5 minus 6, and then dividing both sides by sigma. We don't know what is sigma, but well, the resulting thing would be x minus 6 over sigma is less than negative 1 over sigma. And this is, you see right away that this guy here is z. So we have probability of z less than, well, I don't know what is sigma. Let's call the right hand side a k. We know that there's a k such that probability of z less than k is 0.4013. Something good about this coming this way is that, well, you see there is a negative sign. Sigma is always positive. 1 over sigma is negative. How about we put this negative, and we have that k is negative 1 over sigma. So now it's like we are looking for number k such that probability of z less than negative k is given. If we find it, then we will use this equation and find the sigma for the random variable x. Well, we will need something to do here. This negative, I can drop the negative sign for the normal random variable if we flip the inequality, but this is z bigger than a positive number, so that will give me 1 minus probability of z less than. Why did we turn it to less than positive? Because that's what table for z gives us. And now we know that probability of z less than k subtracted from 1 is 0.4013. And well, if we solve that, basically we know the probability of z less than k is 1 minus 0.4013, which in number is 7 there, and then there's a 9, 8, and then 9, and then 5. So this gives us the probability of z less than k is 0.5983. Okay, now I can use the table for z and find k. So find k from the table for z, or CDF table for z. Okay, here let me just import that table. This is the table at the end of your book. And to be able to find that number, we need to find 0.5987 from the table. So 5987, that number is there, and it is 0.2 and 5. So that means that we found k is 0.25. Okay, we found k. How about the sigma? Well, we will use this and find sigma. Negative k is equal to negative 1 over sigma. That means that 0.25 is 1 over sigma, and that gives us sigma is equal to 1 over 0.25. But what is 0.25? It is same thing as 25 over 100, and that gives me that sigma is 100 over 25, which is 4. Okay, knowing mean of the normal random variable and knowing one probability for that normal random variable, we can find the standard deviation of that normal random variable, and this was one example for such a case.